chapter 5. All right, we're talking quadratic functions. I'm hoping you remember the idea of a basic quadratic equation. So we're going to come down here and we're going to highlight our basic quadratic equation down here. I've tried to color code it for you. The a is in front of the x squared term, and so that is our x squared term. That's the part that makes our quadratic function in a parabola shape. Remember, a quadratic function is the shape of a chain hanging or a ball thrown through the air, whether it's negative, ball thrown through the air, or a chain hanging positive. The b term is our x term. That's what makes it into a line if we didn't have the x squared term. And so if we have the b term, it's usually called our linear term. And our constant term is the c, and that is just a number. The reason it's called constant is because it doesn't have a variable, it doesn't change, it's constant. You're going to see c more and more as we move through the situations. Typically, a, b, and c are integers. So as we're dealing with quadratics, we're dealing with parabolas, a, b, and c are typically all integers. All right? This should be familiar territory that we've done before, but everything this chapter we're going to be dealing with factoring, quadratics, graphing, and things like that. So let's start out down here. I have a couple examples just to do some quick identification. All right, so first of all, we're going to determine whether something is either linear or quadratic. And I'm putting two lines under the quadratic. I'm putting one line under the linear, and that is purposeful. Two lines under the quadratic means, Joey, you have a square term, x times x. One line under the linear means you just have an x with no x squared term. So let's quickly identify here with either an L or a Q. First one, is there a squared term? Okay, so this one clearly is quadratic. Second one, 3x minus 5, linear or quadratic? Linear, because there's no squared term. Third one, x plus 1 times x minus 3. Who remembers how to FOIL? Zach, take it away.
You multiply x by x.
Get x squared.
Squared, and then
Outside.
you do x times -3.
Good. X times -3 is negative 3x.
And then you do
Inside.
1 times x. So
Good. And then finally last times last.
1 times -3.
Okay. That gives me x squared minus 2x minus 3. Excellent job, Zach. All right. Is there an x squared term? So therefore, is this a quadratic? Yes. Okay. So this is a quadratic. All right, last one. You make the determination. Take about 20 seconds, talk it over with your neighbor, and tell me, quadratic or linear? Go. 10 seconds. You must write down your answers. You must write down your answers. All right, time's up. It's the democratic process. I hear we have some elections this week. So, raise your hand boldly and proudly. You must vote. You must vote. Quadratic, raise your hand. Okay, 1, 2, 3, 4, 5. Are you up? So we have division, split party, 5, 6, 7, 8. 8, yes? No. All right, so we have 7. Linear, raise your hand. Ooh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It looks like the linears win. Now, unfortunately, in mathematics, it's not a democratic party. Who would like to debate a little bit to why? Who's on the linear side? All right, Luke, and who's on the quadratic side? All right, Paul. So we have our debate. So I am going to be the moderator, and we're going to go to Mr. Bello first. Mr. Bello, the question is that we're going to pose to you and your constituents, why is this quadratic?
Because it has a x squared.
All right, he says it's quadratic because it has an x squared. All right, Mr. Fritz, it is your chance to, what's the next phrase? Counter his argument, if you wish. You have 30 seconds. Go.
When you would
solve it out, the negative x squared would cancel out the positive x squared, and then it would just be y equals 5x.
So what you're saying is this x squared cancels with that x squared?
Yeah.
Mr. Bello, would you like to come back and have a second rebuttal?
No.
Or you would like to concede this point?
Sure.
And move on to the next question?
Yes.
All right. Wise choice, Mr. Bello. So, what do we call this, guys? Since there is no x squared? Linear. All right. So, let's go back up to the top. Now, we're supposed to identify the quadratic, the linear, and the constant terms. I've left a lot of space here intentionally, so draw a line down. We're going to go across the top. Quadratic term, we're going to put a Q. The linear term, we're going to put an L. And the constant term, we're going to put a C. All right, our first one, our A. What is the quadratic term? Okay, that's the coefficient, so 3x squared, right? The linear term, 2x, and the constant, 6. If they're asking you for the term, you've got to do 3x squared. If they're just asking you, Madeline, for the coefficient, then 3. All right, next one. What is the quadratic term? None. Good. Linear term? 3x. Constant term? -5. By the way, that is a line. True? Y-intercept is -5. What is the slope? 3. All right, next one. What is the quadratic term? Positive x squared. Positive x squared. Linear term? -2x. Constant term? -3. Last one. Quadratic term? Nothing. Linear term? 5x. Constant? Nope. 0. Nice job, Bello. A recovery from the corner. Well done. All right. Because the constant is 0, it still has a point where the y-intercept is, right? Okay, so you obviously, I hope, would recognize the fact that if I asked you for the values of A, B, or C on all of these, you could quickly give me those as well. 3, 2, 6, 0, 3, -5, 1, -2, -3, 0, 5, and 0. So your values of A, B, and C. Make sense? All right, now, just so we can make sure we very clearly can do that, Paul, just to reiterate, we have to simplify first before we identify. Moving on. All right, part 2. Let's look at some graphs here. Parabolas, as you know, are the graph of a quadratic function. We're going to review the ideas of vertex, axis of symmetry, and the y-intercept. So, I'm going to go with blue. Vertex. Put a blue dot where the vertex is on the 2 graphs below. Put a blue dot on both of those vertices. The vertex, remember, is either the highest point or the lowest point of your graph. And I'm going to label V for both with parentheses. All right, who can give me the point vertex of option A? Go ahead, Trevor.
1, -1.
1, -1. Would you agree with them? What quadrant is that in? Review? Quadrant 4. Good, Zach. All right, who can give me the vertex of B? Go ahead, Lydia. -1, comma 2. All right. Second, let's put a red line under the axis of symmetry. And I'd like you to draw the axis of symmetry with a dotted line through each graph. Draw the axis of symmetry with a dotted line through each graph. Remember, the axis of symmetry is the vertical line that goes through the what? Vertex. So draw that dotted line. Why must my line be dotted? Good. It's not a real line. It's just a reference point. It's a point of reflection. It's a point that you get to think about for a long time and move on. Now, equations. Axis of symmetry in red. I'm going to put abbreviation AOS. What is the equation of this vertical dotted line? What is it going through? What axis? It's going through the x-axis, so the equation is x equals 1. What's the equation of this dotted line? Okay, so the AOS, the axis of symmetry, x equals -1. All right, let's switch to green. Underline the y-intercept with green. Let's put a dot for the y-intercept for both in green. What is the value of my y-intercept here for A? 0, 0. True? And my y-intercept for B? 0, 1. All right. Now, let's deal with some reflections. Would you agree that this black point here reflects the green point? What's the reflection of P? P, this P right here. That's 2 away, right? So right about here?
Yeah.
And those coordinates are 1, 2, 3, 1, so 3, 3. You with me? Okay, let's come over here. We've already reflected that P, right? How about Q? What's the reflection of Q? How far away is it? 2 away from the dotted line, true?
Yeah.
So we go 2 away over here. And the coordinates of that are -3, -2. So when you're plotting points with a vertex, obviously the vertex is on the axis of symmetry, and then we reflect off of that equal distance over. Now, a little sidebar that I did not teach you before. We're actually going to do it. Let's talk about max and min before we finish. Does this first graph A, the vertex, is it a high point or a low point? This green point, or this blue point down here. That's a low point, isn't it? So this vertex would be called a min. And this vertex is a high point, so that vertex is a max. All right, now a little sidebar. Any given graph, the most basic graph, which is y equals x squared, starts at 0, 0. The next point is at 1, 1. What's 2 squared? 4. And so if you reflect these points, you get that graph that looks about like so. For a parabola, when you're drawing a parabola, and it's just a positive 1x squared, it goes through the pattern of perfect squares. Over 1, up 1, over 2, up 4, over 3, up 9, over 4, up 16, etc. And so if you have a positive 1 or a negative 1x squared, it follows the pattern of 1, 1, 2, 4. So watch right here. I'm going to kind of do this in yellow. There's 1, 1. Okay, hard to see in yellow. There's 1, 1. There's 2, 4. So as you're looking at the patterns on a parabola, sometimes it's very easy to graph them with the over 1, up 1, over 2, up 4, etc. When it goes up, the x squared is positive. When it's going down, remember the x squared is negative. So I just want to make sure we're comfortable on all the parts of a parabola as we review those ideas, and then we'll move on. All right, example 3. Here I have an equation. I don't have the whole thing. I'm telling you the equation is 2x squared plus a given value c. And all you know is that 0.26 is on the graph. How can I figure out what the rest of the equation is? Give me your thoughts. No, not necessarily. Oh, c is the y-intercept, yeah. Well, I know this point exists, 2, 6. Isn't 2 the x and 6 the y? How many variables do I have here? 1, 2, 3. How many do I know? 2 of them. Can't you just plug things in here? Okay, let's see what we go. 6 equals 2 times 2 squared plus c. I did this problem intentionally because this is a problem in Algebra 1 that typically causes some huge issues. Guess what the issue is in Algebra 1 that they did on this problem that was not correct? They multiplied the 2's, yeah, and then they squared. What do we know now? Square first. Trevor, what'd you say? Those goons. We all used to be one of those goons at one point, Trevor, so we must be careful and give grace. All right, so I get 8. So I get c equals -2. So let's write our equation. Y equals 2x squared minus 2. And there's our equation. So it depends on what they're asking for, the value of c or the value of the whole equation. All right, any questions? I've given you a couple graphs down here because part of your homework is going to be graphing. So you might want to use that to clip, snip, and whatever drag into your graph if you're doing it there. And so hopefully that should be helpful. All right. Now,